All right, so armed with our game plan, let's put it to some use. So looking at our function here, our first inequality, our f of x is x squared minus 2x minus 8. So I see that a is equal to 1, and so we know we're dealing with a parabola that's opening upwards. As far as the x-intercepts are concerned, we're going to set it equal to 0. In this case, we can factor it. So I think a good quick factorization gives us that. Zero factor property, let me cut to the chase. We get x equals 4 and x equals negative 2. So we're crossing the x-axis at these two locations. So if I put a sketch together, right, here's my x-axis, here's my y-axis, right? We know we're crossing the x-axis at 4, 0. We're crossing the x-axis at negative 2, 0. And we know that we're a parabola opening upward. So again, somewhere down here there's a vertex, but that's not important at this point. I just know that this graph is doing something like that. All we need is the sketch. Because now that I have the sketch, what we can basically look for now is where are we at that satisfies greater than 0, right? So that's basically y greater than 0, which again means we're above the x-axis. So looking at this, my graph's above the x-axis here and here. So that starts with our value there and goes in this direction. We're not allowed to be equal to, so this is going to be open. And then that's going to be open and this way. So taking a look at my intervals, it looks like we have from negative infinity to negative 2, right? Open, because we're not allowed to be equal to. Union from 4 to infinity. And there would be your solution for letter A. All right, so again, just following our game plan, right? And there's nothing to it, and we're taking full advantage of our graphing skills and our x-intercept skills. And as I shared with you guys, math does build on itself. So in the next round, right, our function, our f of x is negative x squared plus x. In this case, a is less than 0, so I know we're a parabola that's opening downwards, right? And again, we're looking for where we're above or greater than 0, right? So y is greater than 0. So once we get the graph, we want to know when we're above the x-axis yet again. So to help us out, we're going to find the x-intercepts. So we essentially set our function equal to 0. Okay. I'm going to go ahead and divide everybody by negative 1 to get that negative out of there. And we get x squared minus x minus 6 equals 0. So when I factor this, I think x minus 3 and x plus 2 do the trick. So our x-intercepts are at 3, 0 and negative 2, 0. All right, so there's basically where we're at. So when I go graph this, I know I'm crossing the x-axis at 3, 0. I'm crossing the x-axis at negative 2, 0. Let me change colors here. So our graph, right, since it's opening downwards, is doing something like this. And again, I don't need to know a whole bunch of details, just this. And again, we're looking for where above the x-axis, and that pretty much happens in this little region right there. Again, because there's no equality, right, this would be open and that would be open. So my solution for this particular one would be from negative 2 to 3. So for those stretch of x values, the function is basically above the x-axis, right? And so there's our game plan at work. Last one, in this case, our f of x function is 2x squared plus x minus 6. I see that my a is greater than 0, so I know I have a function that's doing something like this. Finding my x-intercepts, we're going to set this function equal to 0. And let's see, do we have a nice factorization here? I think we do. 2x and x. I believe if we make this 3 and this 2 and that plus and that minus. So negative 3x, yep, there we go. So it looks like we have one x-intercept at 3/2, 0, and another one at negative 2, 0. So if I was to graph this function, right, there's my x-axis, there's my y-axis. We're crossing at negative 2, 0, right? We're crossing at 1.5, right? And we're a parabola, right, that's opening upwards. So my graph, let me change colors here real quick. So my graph has to be doing something like this. All right. One thing that's a little bit different about this is we're allowed to be equal to. So that means the intercepts are going to be part of the solution. They're included. We're going to shade them in rather than open them. And this time, since we're less than, right, we're looking for where we are below the x-axis. So basically for that stretch of values, right, we're negative down there. So it looks like from negative 2 to 3/2, and we're going to have closed intervals because we're allowed to be equal to 0 at that stage. So there's your solution for all three. You can see, again, I'm taking full advantage of the fact that we have parabolas opening up or down. The x-intercepts that we can find in this whole page, I was able to use factoring to get that done. And then putting the graph together, the sketch, looking for the thing I needed, whether I'm above or below, we get our intervals of solution. All right, so there you go. There's your first round. Tougher problems coming soon. Talk to you later.